Okay, so question number 3 asks us at 108 degrees Celsius, the pressure of a 10-liter flask is 874 millimeters of mercury. How many moles? Question mark. So we're looking for moles. So we do have an equation that takes into consideration temperature, volume, pressure, and moles. And if you guys don't know it by now, it is PV equals nRT, where R is 0.0821 liters ATM over moles of Kelvin. So I'm going to go ahead and plug everything in to get N. And I'm going to plug it in by isolating N in a way that when I do the calculations, I will just get the number for N. I wouldn't have to do anything else after that. But before I do that, I have to convert two things. I have to convert this, and I have to convert this. Because in our R, we only have K and ATM. We don't have millimeters of mercury in Celsius. So 108 degrees Celsius plus 273.15 is going to give me 381.15 Kelvin. And then I'm going to go ahead and convert this into ATM. So I'm going to divide this by 760 millimeters of mercury, and then I get 1.15 ATM. So now I have all of my numbers in the right units, and I can go ahead and plug them in. So pressure, which is 1.15 ATM, times 10.0 liters, I'm going to do a little s, over R, which is 0.0821 liter ATM, over mole K. And then I'm going to multiply that by the temperature. So, and this all equals to the number of moles. So I'm going to calculate that, and again, ATM crosses out, liters crosses out, K crosses out. The only thing we need is mole, which makes sense because we're looking for the number of moles. And this gives me 0.3675, which is answer choice number A. Then number 4 is, what is the correct orbital diagram for N3 minus? So when we look at the periodic table, we can see that N is located right here. So we know that it has 1s1 and 2, 2s1 and 2, and then 2p1, 2, 3. But it's not asking for the ground state. It's asking for the orbital diagram for N3 minus. So N3 minus, I'm going to write it right here, has 3 extra electrons. So it's not going to be here. It's going to have 3 more electrons. So it's going to be in this configuration right here, which is 1s2, 2s2, 2p6. So that means that its p orbital is going to be completely filled with all the arrows. So it's going to be, this is going to be 1s. I'll actually write it on the bottom. 1s. It's going to be 2s. This is going to be 1, 2, 3, and this is going to be 2p. So 1s is filled, 2s is filled, and then 2p. This would have been in the ground state, but we know we have 3 more electrons. So 1, 2, 3. So this is the electron configuration for N3 minus, which is answer choice D.